Hey, so I've been working on this issue of adapting the surplus center wheel hub to the surplus center hydraulic motor. And, if I've done everything right, it looks like we could adapt it pretty simply with a tapered to straight adapter that we could make on a lathe pretty simply. I mean, it would be a drilling operation and a boring operation. And if we wanted to do a key, we could do that instead of a keyway. We could do it with set screws on a mill. But real quick, I wanted to show you what I've got here. So this is we've got two parts here. We've got the tapered to straight adapter, and then the wheel hub. So if I can open this tapered to straight wheel hub for tapered adapter. So here's the wheel hub from surplus center, and as always, we've got this parameterized from a spreadsheet. And from the information I gathered, there's no drawing available, but from the information I gathered, these are the dimensions. We've got, as far as the taper goes, the small end of the taper is, I read it on a comment, it's 1.065. So inch and a 16th, and it goes up to where do I have that large diameter? You know what, I might not have that in here. I might just have that set in my sketch here. So I don't have a script for this video, as always. Let's see, it looks like, yeah, I just have this punched in. So it goes from 1.065 to, oh, well, yeah, it would go to the shaft size. So, right, it would go to inch and a quarter, because it's an inch and a quarter shaft, which tapers down. So I read on a comment on Surplus Center that it's a inch and a half by inch and a half every foot taper. So it reduces by an inch and a half in diameter every 12 inches. So that's what I used for the taper to straight adapter over here. And this file is available on the wiki, and this is kind of useful. Like, we could do different bolt circles. We could do 8. Whoops, that's not the right cell for that. No, we could do it like an 8-bolt circle, and there it is. Perfect for you. Anyway, not to toot my own horn, let's go back to the taper to straight adapter. We've got this we've got our dimensions here, and I was playing with these numbers. They're not right. The OD is correct. That's the large. That's what we're going to end up boring our hole to, because basically for this wheel hub, as you can see, this is tapered in this model. If we look at the back side of that, you can see that bore gets smaller. There's the smaller diameter. But what we're going to end up doing is boring this to inch and a quarter. Just running an inch and a quarter drill through there, or running a boring bar at inch and a quarter, and then that would just look like this. It's just a straight bore through. We've still got enough meat here to do that, because the large end already was at inch and a quarter. So we're just removing a little bit of meat from this end where there's plenty of thickness, and should be fine. It is cast iron, so we're not going to be welding it. But that's where the set screws come in later. So anyway, then we go to a straight diameter, a straight outer diameter of 1¼ inch on this adapter. And really, you know, what we would do is probably bore this to a couple thousandths under if we had that capacity. You can either drill it a 64th under and then ream it, or just bore it to the exact diameter you want. Then we've got this taper adapter. So this outer diameter is the same as the bore's inner diameter, and then the way you do this taper, I mean, you can either buy a reamer for like $100, or you just use a boring bar and you set your compound rest at the right angle. I think it's like 7 degrees or something, 7 point something degrees, and you would cut that taper after drilling it out to the smaller diameter of, like, I think I have it at inch 1.06. Now I have it at, oh right, we're adapting this to a 1-inch shaft. So it starts at 1 inch and then goes to, you know, I don't know how I came up. This may be from the comments on the Surplus Center website. But anyway, we can go back to our assembly here, and the way that these would mate together is you just slap this puppy on the inside of the hub, and what I would recommend doing is, let's say there's that motor and it has a keyway, right? We could just put some, and it's a 1/4 inch keyway. Well, we could just drill and tap some 1/4 inch, quarter 20 or 1/4 28 tapped holes, and run a few set screws. You know, this is at least 1 inch, so we could get, 3 of them in there easily. And then to have 3 set screws that plunge through and grab a hold of this and this. You know, if possible, you would make this your tapped hole, because we'd probably be making that out of 1018. Whereas this is cast iron, but you can tap cast iron. It's not ideal. And as far as getting a drill in there to drill those holes, you can just use a right angle drill, or you could potentially just plunge through from the top. I mean, it wouldn't really be an issue with having some holes in this top plate here and just using a long drill bit. It gets a little hairy there, but I think it would work if you really wanted to use this off-shelf hub and the off-shelf wheel motors. So anyway, all this stuff's on the wiki. You can check my log for this. I don't have this assembly file. This is actually really cool. This A2 Plus workbench that I'm using to put these parts together, because what I can do is make changes to, for example, the length of this taper adapter. I could make that a 2 inch. And one of the pitfalls of this document is it's not set for the angle, it's just set for length and diameters, so the taper angle is going to change as you change these values. But I mean, the real life part is going to be the real life part, so that's something I can probably look into changing. But yeah. So anyway, I just updated the length on that, and I can save this part, and then go over to my hub assembly, and I can update these parts, and you'll see that it updates in this assembly view. So that's really cool. This workbench A2 Plus, it's built into the add-on manager. We'll check that out if you don't have it already. And all I've done is a little circular edge constraint. And if we want, we can take a look at that. Oops. We can take a look at this constraint. And you can see, I don't know why this opens so funny, but you can see I've set my offset earlier so that they would line up. You could flip direction on the mate. It's really cool. It reminds me of using SolidWorks. Alrighty.